Thank you, FirstMark, for having me. My name is Alex Schwarzkopf. I'm the CEO and co-founder of a company called Pillar. And like every good startup, we did not start in construction, which I'm going to talk to you about today. But just so you guys have this in the back of your mind, we like to think about ourselves as protecting the health of commercial buildings, starting with construction. So today, I want you to think about a building more like a body as opposed to a building, because it's honestly not too far off. That's back. There we go. All right. So before we actually got involved with this, I had a couple failures, which I'm more than happy to share with you today. We got started actually in wearable technology. So when I was in university, I studied at Wentworth Institute of Technology in Boston. Yes? Boston. Yeah. Always get one, at least. So one of the things that we set out to do our senior year was work on a problem that really inspired us. And instead of figuring out 6 different ways to boil water, as a lot of our colleagues decided to do, we wanted to attack something really meaningful. And we saw this movement in sports around mental health. I mean, you guys have seen some of the challenges that the NFL is facing and some of the players where they've had deep mental depression, and unfortunately some folks have actually taken their lives. And it's because of concussions and what happens when you repeatedly impact the brain, right, against an unmovable object. And so what we set out to do was actually start to quantify how much force, how much deceleration, and how much rotation can a brain sustain before it's actually going to cause neurological damage. Now, we're not qualified to do this at all, but we wanted to try. And we actually went on a really interesting journey. I'm going to share a little bit about this with you. The brain actually releases a protein. It's a trauma marker when you have a concussion. And what's interesting is it's like a fingerprint. So if you know, this gentleman from Boston and I get in a fist fight, right, and he knocks me one and I knock him one because we've been drinking at an Irish pub a little bit too long, he may have a concussion and I may not, and his brain will produce a certain amount of this protein, mine may not. And the problem is that we don't know how much force or how much acceleration his brain experienced before that protein level was measured. So, you know, we can tell you if you have a concussion, but we don't really know how many whacks it takes till you actually get one. So on the left-hand side here, you'll actually see our first prototype. So this was our first crack at it. Lance Armstrong, Live Strong. We actually just stitched some like force-sensitive resistors to the hat, put it on a mannequin, started whacking it against things. And one of the things we figured out was that those aren't sensitive enough. For the tech geeks out there, and I'm trying to make this as technical as I can without losing the general audience, because I am an engineer at heart, but I've had to learn how to tell stories, which is still something I'm trying to figure out how to do. But they just wouldn't respond fast enough. I mean, we're talking about milliseconds, sometimes microseconds, that you have to measure something. And so we actually moved away from that and started actually building a small wearable that sits in this pouch. And I don't have a picture of it right now, but it looks like a Pringles potato chip. So if you guys all know what a Pringles looks like, so you'd actually stick it on the back of your head, and we were monitoring the linear deceleration and also the rotational acceleration of the brain. And what we were finding is that it's a really hard problem to solve. So one of the challenges was, okay, you put this on an athlete, how do you make sure you're measuring from the same point on the back of the head all the time, right? Is it on? Who's responsible for making sure people wear it? What's the liability if it doesn't work properly? Who's responsible for that liability? And ultimately, who's getting sued? Because if I tell you something and I say, this is going to protect your child, and it doesn't, that's really hairy, right? And one of the interesting things is, from a technological perspective, it solved the problem. We were measuring things, right? We were actually getting data. We even got so far as to begin working with one of the professors at Harvard that was doing some brain research And when we went for funding to take it to the next level, some of the investors were just not comfortable with the risk profile. We couldn't explain, how this would scale and how this would work in reality. And it really put a hard stop on how I saw the world, because from an engineering perspective, it worked. We solved the problem, but the problem was actually a social one. It wasn't the technology, and that was the first moment in my life that I had ever been like full stop, not going to work for not a reason I thought, right? And it was incredibly discouraging, but kind of like a phoenix. So we put them on lacrosse players, and we had them run around the field, checking each other and stuff, so they were our guinea pigs. But ultimately, got a bunch of press, got in the newspaper. Things looked like they were going really well, but it didn't really go anywhere. So I actually took a little bit of a hiatus between the time I graduated, and I was working with a startup that was doing some work in Africa, and specifically in Somalia. Now, I have no business going to Somalia. Lots of people told me that. But we were building scalable wireless hotspots for nomadic tribes. Big challenge in these areas is there's no cell towers, but Africa's going mobile. They're going wireless. They're just totally blowing by copper. And so how do you give these people the power to transact and conduct business digitally if there's no connectivity? So that was one of the things that we started to work on. I took a little bit of a hiatus, did that for about 9 months, never ended up going. Turns out it's really hard to raise money for a company in Africa. That was my other fundraising failure. But I got to travel the world. I went to Turkey, Indonesia, all over the place, and learned really, really valuable lessons about what not to do. So we came back to Boston and met these two guys because we were so passionate about the concussion monitoring devices. We were like, hey, what if we could put that somewhere that it's not such a sensitive topic, right? Maybe more of an industrial focus. And so one of our buddies comes out to us. He said, why don't you put those in hard hats? It's the same kind of problem. Just throw them in there and start monitoring data. These guys get concussions. It's a thing. And so we found these two guys. They're actually alumni of Wentworth. And sat down with them and basically was like, hey, would you guys put this in your workforce? And within about 20 minutes of pitching, they were like, nah, this is not valuable enough. Sorry, try again. And I remember there was this moment when it was like a what and moment where all of a sudden Don goes, well, what if you guys monitored other conditions? Like, we struggle to know what's happening on our construction sites. They're massive projects. I think I have a video. Yeah, like, tell me what's going on there and how, right? So this idea that I call it order to chaos. It's honestly amazing that like this thing exists because you have 300, sometimes 1,000 people working on the same site doing different tasks at the same time. And it's incredibly chaotic, right? And so we looked at this and said, yeah, there's got to be a problem in there somewhere that we can kind of bite off. So Don goes, what if you could monitor just environmental conditions? What if you could take these little small devices, make them bigger, and put them all over my construction project? And we said, well, why? He's like, well, I deal with this stuff. So these are actual real-life examples of losses that have occurred in construction that we know about now. But as we started to dig into this problem, we started to realize, like, there is no real good solution to some of these challenges. So, for example, when you're building a wood frame building and it rains and you don't dry it out quickly or properly, what happens to mold? What happens to wood when it's wet? It grows mold, right? Cutting boards, butcher blocks, you've all seen it. Same thing with the building. Mold is considered to be what you all would call the silent killer, right? If you've ever been in a house that smells kind of funky, you start having respiratory issues. You can have asthma, you can have things like that. What people don't realize is during construction, they're subjecting the building to all of these conditions. So by the time it's built and it lasts for 70 years, it could have black mold behind the wall. Scary enough, I've seen this in hospitals. I'm not even kidding you. Hospital renovations, they rip down a wall, black mold all the way down the wall. And you just don't know. And the challenging part is with technology, you can prevent some of this stuff. The way that people detect water leaks from freezing pipes is they got a guy walking around at night, looking around, sticking his finger in the air. Oh yeah, I don't think it's gonna freeze in here tonight, we're good. And then lastly, hopefully this never happens to you, but fire. I mean, it's wood, there's combustibles, paint, adhesives, all things that can combust, and it happens. So Don goes, yeah, if you could give us some type of technology that we could put over this project, it would basically give us some really interesting insights, prevention being the big one, mitigation being the next piece. And so we started to do that. I want to pass around, this guy. This is our first prototype. Built that with like $30, uses Wi-Fi, it's not that great. But we sold 2 pilots for $6,000, and then I used that to actually turn into $5,000 a piece from these guys, and then I leveraged that to raise another $10K. So we had a total of $20K to start the company. Only got about 3 minutes here, so I'm gonna blow through this, so stay with me. So this is actually on that site, right? So we put up 30 of these. We started to see some really interesting stuff. Our hypothesis was sensors on construction sites, data is gonna tell us a story, data is gonna lead us to mitigation and prevention of damage. So this was in the winter. We caught a water leak, and we caught 2 conditions that could have led to frozen pipes. This was a school that needed to open that summer, right? So just by monitoring this stuff, we were able to give them real hard information to improve the quality of that project. So we knew we were kind of onto something. So part of our story, we were like, oh, what do we do for funding? I happen to know the folks at 1517, which is the Peter Thiel-backed fund. And then we shortly after won the Forbes 30 Under 30 pitch competition, which Ashton Kutcher was an investor in. So right off the bat, great press, having a good time. It's just some screenshots for you. They've been incredible, by the way. Going through rebranding, better logo. So this leads us to what we're at today. We basically have built what I like to think about as a nervous system for commercial construction sites. Each pod gets placed every 2,000 to 3,000 square feet, so it's a nerve ending. There's hundreds of these things on a major commercial project. We just pulled off of World Trade Center down here. And that creates almost like a resting heartbeat. So if you think conditions don't change that often, that fast, but when they do, that tells us something. And that's what we look for in the data. So all that data, temperature, humidity, dust particulate, noise, pressure, light, carbon monoxide, volatile organic compounds, it's all in that box. Gets pushed to the platform pretty much in real time. We use LoRa. Can't go through walls with Wi-Fi, so got to use a different wireless protocol. You also don't have power. You don't have any infrastructure in construction. So these are all really interesting, unique challenges we had to solve in order to get this done. And lastly, we like to think about it like having a supervisor on site 24/7 that's able to be everywhere all at once, which is totally different than one guy walking around a project every 45 minutes. So we started our journey in Boston. These are my 2 co-founders. We were in residency at the Autodesk Build Space. That's just a nice photo of Boston. And then we made the move. Big reason, Jenny Fielding is in the crowd tonight. She's going to talk to you about the IoT, well, her new program, Techstars New York, but we actually had the pleasure of going through the IoT program in New York. That brought us down, that connected us with the ecosystem, got us involved, and really allowed us to make New York our home, and we're here now. So basically, with the last, I'm over time, but I wanted to basically say, where do we think this is going? My belief is that construction is the perfect opportunity to embed technology in the building that is going to give us the data about how healthy that property is for the next 50 years. And it's only feasible through the construction cycle, because it's not economic if I rip down that wall, stick something behind it, and then put that wall back up. It has to be done in the design process. And so what I think you're gonna see is the next generation of buildings having this nervous system actually embedded into the walls, so it's able to talk to you and tell you how healthy it is, so that when you go into the hospital, you know there's no black mold behind the wall. So that's what we're working on. Thanks so much. I know I didn't have much time, but I'll be around, ask me any questions, and yeah, I'll take the applause. Thanks, guys. Thank you so much.
Very nice, thanks. Just one question from me. What's your sense of the level of readiness of this industry, which historically has not been super data-driven, super open to new technologies? What's the level of readiness and appetite for this?
Yeah, so it's a fairly complex question. Just some high-level stats. Construction globally is a $10 trillion market. In the US alone, it's 1.2 trillion with a T. The estimation right now is if we digitize technology or digitize the construction process, basically automatically capturing data, getting insights, taking action, we could save 700 billion to $1.2 trillion off of that entire number globally. So there's a massive opportunity here to change the way we build, right? To extract efficiency. Also, productivity curves in construction have actually declined against manufacturing. Manufacturing's increased twice, I think, in the last 20 years. Construction has actually plateaued and actually declined in certain areas. So construction margins are 2 to 3%. They're terrible. Projects are getting more complex. Insurance companies are demanding transparency. So you have this confluence of trends where if you don't use technology and you don't move into the future, you won't survive. And so I hope that answers your question. So I think it's now.
Thank you.
Is there also more automation in construction, which would also be a contribution to your technology?
Correct, yeah. So a big component of what we're seeing now is an unskilled workforce. So that leads to higher risk of property damage and unsafe working conditions. The robotics is a really interesting area that we're starting to see in construction. My concern, though, is unions. So unfortunately, the labor rights, right? I'm not political. I'm not saying that's good or bad. I'm just saying, again, back to social factors that inhibit the introduction of new tech. That is a challenge I think we have to overcome first.
Hi. Hi.
Yeah. Hey.
Okay. Thanks for your presentation. Really fascinating.
Totally forgot.
Just a quick question from some presentation that I've been reading or seeing. I have the feeling that now, construction companies are putting a lot of sensors everywhere. Could be on the pipe, could be on the heat. So how are you competing with those sensors?
Yeah. So
are you bringing anything?
What does it look like?
Yeah, the plus, what the minus, what are we doing here?
So you raise a fair point, and actually what I would say is a lot of the sensor technology we're seeing is retrofit into existing buildings. I have not seen good scalable technology that's used in construction yet. And we work with most major insurance companies, and we work with some really large builders. What I can tell you is there's legacy solutions that were designed for other markets that have been adopted. I've even seen Nest thermostats in construction sites because there's just no real good solution. And a lot of the technologies are one-offs. So you'll have one temperature sensor, you'll have one carbon monoxide sensor, you'll have one particulate sensor, but now you have 3 things, right? So now I have to manage 3 things in that mess that I showed you. So the more you can simplify and distill down the technology and the ease of use, that's where we think we're going to have success. But I haven't seen a good additional scalable sensor solution, at least in construction. Yeah.
Hey, great presentation, great idea. I'm curious about your vision. So you think buildings are going to be much more alive, right? So maybe like a pillar, but a fixed pillar, forever there. We know that communication protocols, technologies, batteries, all those things change very quickly. You have a building even for 50 years. How quickly does the technology become obsolete? Why not just stay with something like yours, maybe even smaller, where you could just plug it and unplug it every so often instead of just having behind the wall next to the mold?
Do you want a job?
Sure.
Okay, we should talk. So you raise a really great, yeah, you raise a great point. So the basic question is, how do you future-proof, right? So there's things, there's like legacy things like temperature sensors that aren't going to change, but what may change is how you talk to them. So my idea would be almost like a modular infrastructure that absolutely, employing that same concept that I had there, you can basically click in, click out the new set of hardware, the backbone, if you will, and then the things that aren't going to change or are going to be the same for a long time, you leave in, and you can either use, simple communication protocols or, future-proof protocols. I would be, let's just say you can get very creative with that without giving away the farm. Yeah.
All right. Thank you so much.
Thanks everybody.
Perfect. Thank you.